As we continue our discussion about space figures and polyhedron, we're going to start looking at surface areas. Today we're going to look at surface areas of prisms and cylinders. Before we do that, we need to make sure that we've got some vocabulary under our belt. A prism is a polyhedron with two congruent parallel faces referred to as bases. In this figure on the left, those bases are pentagons because they have 5 sides. The other faces are referred to as lateral faces. Those are the ones that connect the two bases. A prism is named by the shape of its base. So if we look at the one on the left, this would be what we call a pentagonal prism. If I can spell today. Pentagonal prism, because its bases are pentagons. The one here on the right, we have bases which are triangles, and then the lateral faces are rectangles, so this would be a triangular prism. Okay. It's important to be able to distinguish which shapes are the bases and which shapes are the lateral faces as we go through to find surface area. Okay. Now a little bit more, because height is going to be important. The height, or the altitude, is the perpendicular distance between the two bases. Now, in this figure, and this would be a rectangular prism, and with rectangular prisms, those you can consider the bases to be really any of the opposite sides, so it gets a little interesting in that respect. The height is the distance between them. It's really nice when you have a right prism because the lateral faces, the lateral edge, or one of those faces, is the actual height. Sometimes, though, you have an oblique prism, so it's kind of like someone took it and just pushed it over a little bit, like the Leaning Tower of Pisa. All right, then the height is going to be another distance, so we'll have to have that measured out. It won't actually be the length of one of the sides the way it is in a right prism. Now, for our purposes, as we go through this chapter, unless otherwise stated, we're going to assume that the prisms are right prisms. Okay. Now, for surface area, the lateral area of a prism is the sum of the areas of the lateral faces. Okay. So we would find, in order to do that, the product of the perimeter of the base of the figure and the height of the prism. Because if you think about the lateral faces, right, if I go all the way around and add all those up, I've basically gone around one of the bases. So that's why we have the perimeter of the base times the height. This helps us find the surface area, because in order to find the surface area, what we're basically doing is adding up all of the sides, all of the figures. So we're going to have the lateral area plus 2 of the bases, because if this is a base, then this top is also a base. So we have 2 of those bases, and then the sides are our lateral area. So we have to add all of that together to get surface area. So in this figure, we want to find the surface area of this prism. The bases are the 2 triangles, right? And then we have the lateral faces, which are the rectangles connecting them. So remember, surface area is lateral area plus 2 times the area of the base. Now, in order to find the lateral area, we need the perimeter of the base times the height, plus, in this case, 2 times the base, which is 1/2 base times height, because the bases are triangles. Now, keep in mind, the height of the triangle is not necessarily going to be the height of the figure. So we need to keep those separate. Now, we need to find the perimeter, which means I need to find the length of this side, because I need the perimeter of this particular triangle. It is a right triangle, so we can use our Pythagorean theorem of a squared plus b squared equals c squared. What I have are my 2 legs. I'm looking for c. Now, I hope that you recognize this as a particular type of right triangle, and so you don't have to go through this process. But if you don't, 3 squared plus 4 squared equals c squared. So we have 9 plus 16 equals c squared. 25 equals c squared. So c is 5. So what we have is a 3, 4, 5 right triangle, which I hoped you recognized, so you didn't have to go through the Pythagorean theorem. But if not, Pythagorean theorem is the way to go. So perimeter is going to be 3 plus 4 plus 5, so we get 12, times the height of the figure, which is 6, plus 2 times 1/2 times the base of my triangle, which I'm going to consider the 3 to be the base, times the height of my triangle, which I'm going to consider to be 4, but it really doesn't matter. Alright, so 12 times 6, we get 72. And we're going to add to that 2 times 1/2 is 1, times 3 is 3, times 4 is 12. So we get 84. Now we're finding surface area, so our units are still squared, so we have centimeters squared. Now in this figure, slightly different figure, now we have a hexagonal prism because the edges, the bases, are hexagons. Again, we're going to need to find lateral area, area of the base, and then the surface area. So lateral area, remember, is the perimeter of the base times the height of the figure. Well, the perimeter of this base, it tells us that all the sides are the same, so there's 6 of them, so I have 6 times 6, which is 36, times my height, which is 12. Okay, so we get 36 times 12. We have, in our calculator, 432. Our unit is meters, so we have meters squared. Now the area of the base, this is a hexagon. It's a regular hexagon, so I can use my formula for a regular polygon, which is 1/2 times the apothem times the perimeter. Alright, so 1/2, I don't know the apothem, going to have to find that, times the perimeter, which we already found up here, is 36. Alright, now, because it's a regular polygon, I'm going to take my triangle of interest. I know that this part is 6, right? If I draw in my apothem, I know this part is 3. If I find the measure of this angle, remember we do 360 divided by 6 because there's 6 of these triangles going around. And that gives us 60. Take half of it is 30. Right? So hopefully we recognize this as a 30, 60, 90 right triangle, which means the length of my apothem is the short side of 3 times the square root of 3. So we have 3 radical 3. We do this multiplication. So I have 1/2 times 3 times 36. Now I'm going to do 1/2 times 36, which I get to be 18. Multiply that times 3 is 54. My radical 3 just comes along for the ride. My unit is still meters squared. Now surface area, remember, surface area is lateral area plus 2 times the bases. Well, we found lateral area first, so we have 432 plus 2 times the bases, which is 54 root 3. Alright, so we have 432 plus 108 times the square root of 3. If I put this into my calculator and I round it, let's round it to the nearest whole number, I get 619. My unit is still meters squared. Now when you put this into the calculator, I recommend doing 108 times the square root of 3 first and then adding 432 to it. Otherwise it might think you're doing 432 plus 108 and then multiply that whole thing times the square root of 3, and that's not actually what we want. Another figure that we're going to look at are cylinders. Okay? Cylinder is a solid that has bases which are in the shape of circles. Okay? The height is the distance between the bases, and again we can have a right cylinder like the one at the top, or an oblique cylinder like this one down here. Again, unless otherwise stated, we're going to assume that the cylinders are right cylinders. And if we think of this and kind of unfold it a little bit and flatten it out, to find the surface area, the lateral area is going to be the distance going around. So if we kind of unroll it, we've got the height, we unroll it flat, we end up with what looks like a rectangle. And the length of the rectangle, or the base of the rectangle, is actually the circumference of the circle, of the actual base. So our lateral area is going to be circumference of a circle, which is 2 pi r, times the height of our cylinder. The surface area, we're taking the lateral area plus the area of both bases. The bases are circles, so we have 2 times the area of a circle, or 2 pi r squared. So let's look at an example. We have the radius of the base of a cylinder is 4 inches and its height is 6 inches. What is the surface area of the cylinder in terms of pi? Now, I'm a fan of pictures, so I'm going to draw my cylinder. The radius of the base, right, it's not perfect, but we still draw it in there, is 4 inches. The height is 6 inches. Okay, surface area is lateral area plus 2 times the bases. Now, lateral area, remember, it's the circumference of the base, or the perimeter of the base, so 2 pi r times the height of the figure, plus 2 times the bases. Bases are circles, so we have pi r squared as our area. Alright, so we have 2 times pi times our radius, which is 4, times our height, which is 6. And then we're going to add onto that 2 times pi times 4 squared. Alright, we're leaving it in terms of pi. So 2 times 4 is 8, times 6, 48 pi. We're going to add to that 4 squared is 16, times 2, 32. Alright, 48 plus 32, we have 80 pi. Our unit is inches, so our answer is inches squared. So we have 80 pi square inches. Okay. Alright, last example. Radius of this particular cylinder is 10 centimeters. Its height is 9 centimeters. So again, I'm a fan of pictures. Doesn't have to be perfect. Alright, height of 9 centimeters, radius of 10 centimeters. You can obviously see that this is not drawn to scale because it looks taller than it is wide. Alright, we want the surface area. So surface area equals lateral area plus 2 times the bases. Lateral area is the circumference, or the perimeter, times the height. And the bases are circles, so we have pi r squared. So we have 2 times pi times a radius of 10 times the height of 9 plus 2 times pi is the radius of 10 squared. Okay, so 2 times 9 is 18 times 10 is 180. 10 squared is 100 times 2 is 200. So 180 plus 200, we have 380 pi. Our unit is centimeters, so our answer is centimeters squared. So the surface area of this cylinder is 380 pi square centimeters.